5.4, solving compound inequalities. Okay. A compound inequality containing, it's an O, and a compound containing and is only true if both inequalities are true. Okay, a compound inequality containing and is only true if both inequalities are true. Later, we'll have a compound inequality containing or is true if one part is true. Okay, but when it has and, both have to be true. Okay, both have to be true. To drive a car, you have to be one, old enough, and two, have a driver's license. Okay, so both have to be true. So in an example, we have x is greater than or equal to 3 and x is less than 7. My cord fell, so hopefully everything's still working. All right, continuing. X greater than or equal to 3 and x is less than 7. So we have the inequality. It's going to be like this. X, the bar, 3 less than or equal to x less than 7. The graph is going to be the intersection, the overlap. The graph is going to be the intersection. So 0, 3, and 7, and x is greater than or equal to 3, and x is less than 7. That's an open circle. The graph is the intersection of those two. The intersection is where the two graphs overlap. So here's another problem. -2 is less than or equal to x minus 3 less than 4. I have two inequalities in here. Okay, this is a compound inequality. So what we have to do is we're going to add 3. But when we add 3, I'm going to add 3. I'm treating both inequalities as if they were equal signs. So when I add my 3, I am going to add the 3 to basically both sides. I also have to add it in the middle to get rid of it. So I'm going to add it in that case like that. I'm adding the 3 here, what it's greater than. I'm adding the 3 over here, what it's less than. And I'm adding the 3 here so I can isolate my x and just get x. So a -2 plus 3 is 1 less than or equal to x less than, and 4 plus 3 is 7. So we'd have a -1, or excuse me, 1 less than or equal to x less than 7. Our graph will look like this. 0, 1, 7. X is greater than or equal to 1, so that's a filled in circle. X is less than 7, that's an open circle. Again, less than 7 and greater than or equal to 1. So my graph is the intersection of the two. Let's look at another problem. Y minus 3 is greater than or equal to a negative 11, and y minus 3 is less than or equal to a negative 8. Okay, so we solve each part individually. And when I'm solving them, I'm going to add 3 to both sides here. So I get y is greater than or equal to a negative 8. And here I'm going to add 3 to both sides. And I get y is less than or equal to a negative 5. Okay, so I have to go put those together in a compound inequality, in which case it'll be y, the bar, a negative 8. Y is greater than this, so less than or equal to y. So y is greater than or equal to a negative 8, and it's less than or equal to a negative 5. Okay, you need to be able to write that out that way, in that form, that set notation, and then also graph it. And when we graph it at a negative 8, and we're going to have a negative 5, and both are filled in circles. So we have one where y is greater than a negative 8, and the other one y is less than a negative 5. So we get the intersection of those two, and we're going to have the graph that looks like that. And I'm just going to, so we don't have those arrows in there now. We get that. Okay. The next problem, I forgot to tell you in this last one to do it on your own or try it on your own. But here, this next problem, try this on your own. 6 is less than or equal to r plus 7, which is less than 10. Compound inequality here, okay? I'm going to subtract 7, but I'm going to subtract 7 to all 3 parts. So I subtract 7, subtract 7, subtract 7. When I do that, it's going to be a negative 1 is less than or equal to r, which is less than 3. And then I graph it. Negative 1, 3. I have a filled in circle here. I have an open circle here. And one of the things you want to double check is make sure that we have both arrows going to the middle here. R is greater than or equal to this one, so that's this direction. And R is less than 3, that is this direction. So they overlap, they intersect here. Okay. Now, in the next set of inequalities, we're going to have the OR situation. So here we have a compound inequality containing OR is true if at least one of the inequalities is true. Okay, so here we have compound inequality. So we have two separate inequalities. This is going to be true when it has an OR if at least one of the inequalities is true. Its graph is the union. It's going to be the union of the two separate graphs put into one. So for example, we have x is greater than 2, or x is less than or equal to -1. Okay, it'll be true, this will work, it's going to happen if one case, x is greater than 2, or if x is less than or equal to a -1. So the graph is going to be one part, I'm going to do the -1 part first. X is less than or equal to a -1. So at a -1, it's going to be less than or equal to, it's going to go in that direction. Or at 2, x is greater than 2, that's an open circle, and it's going to be greater than. Now, for an or situation, it doesn't, the arrows don't have to go in opposite directions. They can both go in the same direction. They can both point to the middle, okay? A compound inequality containing or is true if at least one of the inequalities is true. Okay? One of the things in terms you're going to be used in your word problems is the word within. Okay? When you see within, that means it includes the point, so that's going to be less than or equal to or greater than or equal to, the word within. If it's between, then that means it is strictly less than or greater than. So when you get to those word problems, if it says it's within, so-and-so scored within 18 and 37 points, okay? Well, that includes the 18 and 37. If we say he scored between 18 and 37 points, that means he scored greater than the 18 or less than the 17, but it does not include the 18 or the 17. All right, I'm going to have to finish these next couple examples in the second video. So watch part 2.